Hello and welcome to the Measuring What You Want to Know video series, Part 5, Creating and Evaluating Multi-Item Measures. When might multi-item measures be necessary? Well, the things we want to measure may have multiple aspects. Things such as depression, physical function, and sexual function often include lots of different things, and so we need multiple items to address each of those different aspects of that thing we're measuring. And another reason why we might want multiple items is to improve the reliability or the precision of the scores. Because generally, the more items we administer, the greater the reliability of the scores we obtain. Now, it's important to note that special expertise is needed to develop and evaluate multi-item measures. And so the purpose of this tutorial right now is to give you an overview of the basic steps that are involved so that you might collaborate with an expert more effectively. So let's look at a bird's eye view of the general steps for multi-item measure creation. It really begins with determining what concept we want to measure and why. And we might start out with sort of a fuzzy notion of what it is that we want to measure. Maybe it's something like fatigue. And to improve our understanding of this, we might go collect some qualitative data to understand the meaning of the concept. And in talking to people in focus groups or one-on-one interviews, we might get a much clearer picture now of what is meant by fatigue. We're in a position to say what it is. And once we're in that position, we can try to write some items that we think measure the concept that we're interested in. And at this point, we can say that we have a preliminary measurement model that relates the items we've written to the concept that we're trying to measure. Having written these items, we then want to test those items for understanding through cognitive interviews. And so as a result of these one-on-one interviews, we find out how people understand and respond to the items, and on the basis of that, we might find out that some of the items we wrote aren't too great, and we may find that there are a couple new items that we could add in that would help our understanding of this thing we're trying to measure. Now with the items in hand, we can administer them to a large sample of people. And doing that permits us to do a few things. We can use psychometric or statistical analyses to see how well the items are working and to develop a scoring method. And so we're going to collect a lot of data on maybe hundreds or even thousands of people with our items. And we're going to find out how well do those items fit that picture that we had, that model of the thing we're trying to measure. And then if it does fit well, how do we come up with a score? How do we combine responses across the multiple items to arrive at a single score? So for both those things, we use psychometric analyses, which are special statistical analyses. Now with a score in hand, we can go evaluate the reliability and validity of the measure. And recall that validity means it's measuring what it's supposed to measure, and reliability means that it's measuring it with little error, sometimes known as precision. Let's go through a quick example of each of these. So one type of validity evaluation concerns convergent validity. This refers to the extent to which our new measure's scores are associated with another measure's scores that's supposed to be measuring the same thing. And so in this example, we've got a relatively new measure of depression, the PROMIS depression measure, and we'd like to know how it relates to another popular measure of depression used in research, the CESD. So the CESD is on the y-axis, and on the x-axis are depression scores from the PROMIS measure. And we can have a look at those data and see that it's actually a fairly strong correlation there of 0.84. And this strong correlation would give us greater confidence that the type of thing being measured by the PROMIS depression measure is similar to what's being measured by the CESD. It's convergent validity evidence. Let's look at an example of a reliability evaluation, and there are a few different ways to evaluate reliability. But one important way is based on the idea that scores should not change over time when the person's health state remains the same. The person's feeling exactly the same, their score shouldn't change. And if the scores do change, we assume it's due to random measurement error. And so the type of reliability that this addresses is test-retest reliability. And so I'm going to assess people at time 1 and then again at time 2, and I'm going to make sure that these are people who did not undergo any clinical change. These are stable people. And so I look at the relationship between those time 1 and time 2 scores, and here the test-retest correlation is 0.85. And generally for group level research, that is research where we're trying to make conclusions about how some groups might differ or what happens to groups over time, we would like to see a test-retest correlation of 0.7 or higher. So this correlation of 0.85 would be some very positive evidence of test-retest reliability.